Next part of today's session, stepper motor control. We're going to look at some different algorithms, different methods of stepping a motor, so that we can see how we do the full step, half step situation. We're going to look at anti-resonance and its implications, and a little bit about drive circuits. Okay, so although we said we can accurately position by moving a number of steps, counting that number of steps, we know we're gone from A to B. The issue there is if we have a situation where we lose a step, we'll be out of position. So that's a problem if there isn't any feedback. If there was feedback, you'd know you'd missed that step. You can do something about it. But if there isn't any feedback, and you've said 1,000 steps is a metre and you go and miss a step, but still count it, you won't have gone 1,000 steps. You won't be the distance you thought you were. So that's one part of that implication. So we've already talked a bit about the way these motors step, and there are different stepping modes. So a full step in our 4-pole, simple 4-pole motor, 90 degrees. Half step would see that moving 45 degrees, and micro step another half of that again, 22.5 degrees. Okay, and so you can see how with our variable reluctance motor, with the small serrations gearing on the edge, we can move in quite small steps. So, bipolar full step control. What we're going to look at is how we switch. Want you to not to worry too much about pick microcontroller and motor drive at the moment. Really want to concentrate on the different orders where and directions we're energising the two coils A and B to get this motor to step round in a particular number of degrees. Okay, so what they're saying up here is step 1 is going to be to energise, put a positive or a logic 1 on the A end of coil A. Step 2 we'll do the B end of coil B. Step 3 is to energise or put a logic 1 on the A dash of coil A, i.e. current in the opposite direction, followed by B dash of coil B. The next step in the sequence would be to go back to there. Yeah, if we went from there, A to B dash, to A dash to B, back to A, the motor would go in the opposite direction. Yeah, so we're just going to look at that in detail. So if we look at the first step here, and that's greened out up here, we're in the first step of the program. We put logic 1 on the first port, output port. We've got logic 1 on the port A, current flowing in there through that coil, generate a north pole here, south pole there, and the rotor has gone through 90 degrees anti-clockwise and aligned with those poles. Yep. The next step is to turn the logic 1 off A and put it onto B. So now we've got logic 1 on here, we've got current flowing in this direction, through there, up there, back in there, a north there, a south there. That route has now gone through another 45 degrees by turning one pole off and the other pole on. One port on, we put a logic 1 onto B. Yeah. Then this slide is an attempt to show all four steps in one go. Just see if we can zoom in on that a little bit. Right, so here's a logic one on there. We've gone that way. Step 2 is a logic one on port 2. We've moved so we're going in that direction, aren't we? Like that, yeah. So that's gone like that. That's gone like that. Permanent. Moved like that. This one moved from there to there, for instance. Then we have gone logic 1 on port 3, which has moved from there to there, and logic 1 on port 4 moved from there to there. We've done one full rotation in very big 90-degree steps. Yep. By energizing in those logic sequences. Considering the black box, the PIC controller would tell the motor drive to turn on the variable port, so the motor drive is doing the job of handling the high current needed to actually energize the rotor coils. You wouldn't get that directly from the PIC. Yep. So it's an interface between the two. Don't worry too much about that at this stage. So that's full step control. If we look at the sequencing on full step one phase on voltage sequence, so we're only turning one phase on at a time, okay? We're sending pulses out to the two coils like that. So first of all, we're energizing the A coil in one direction, then the B coil in that same direction, followed by the A coil in the opposite direction, B coil in the opposite direction, and this is a repeat of step 1 there, and we just carry on doing that, and the motor carries on going round for as long as we carry on doing that sequence. How do we speed it up? Frequency of the pulses, yeah? So quite an easy motor to control the speed of as well, yeah? The rate that we throw these pulses at it is going to vary the speed. It's quite easy to do speed change. Yeah? Determining the speed. Number of steps per revolution. So we need to know how many steps. Well, if we want to know how many steps for every rotation, we divide 360 degrees by the angle for one step. So in this case, we got 4 steps per revolution. Number of pulses per second. Yeah. So if we want 120 RPM, divide that by 60 to turn it into revs per second. multiplied by the 4 steps per revolution. We need to provide 8 pulses per second to get 120 RPM. Yep. So that's 8 hertz. Yep. Not particularly difficult calculations if you need to do them. Yep. Full step, 2-phase on, bipolar. Right, so here we're going to do have 2 steps, 2 things energized at any one time. Looking at this, if we have step 1 as energizing port A in the normal direction, port B in the normal direction, we then reverse A and leave B where it is. Then we reverse B, so they're both reversed, and then we leave B reversed and we put A back to the normal direction. So in that sequence there is always 2 poles energized. We've got 2 norths for our south to align with and 2 souths for our north to align with. Yep.
Then the switch speed just stay on.
Sorry?
When it goes from A to B to A dash to B,
yeah.
does B just stay on, or does it switch on a little separate? Or
No, that will stay on. Yeah. As you'll see in a minute, because we've got to go through the sequence like we did before. So that's our first step. We're aligned to the northeast, just so as I remember which way we're going. So the second, at the moment we're energized coil A in what we call the normal direction, and coil B in the same direction, from A to A dash and B to B dash. Second step is to leave the coil B energized as B to B dash, so coil B will end up, will stay with the north at the top and south at the bottom, but we're going to switch coil A so that we're energizing that in the reverse direction. So we're going to change the current here so the A poles are going to flip over. This is going to become a south, that's going to become a north on the next slide. So this changed, therefore we've moved round from here, that's where the south pole, north pole was there, weren't it? Previous one, just go back again. Yeah, north, oh, south on the, I'm looking at the ruler, south was at the northeast, south was at northwest. So we've moved 45 degrees in that direction. Yeah? So we've left B coil the same, but changed the direction of A. The next thing we're going to do is change the direction of the B coil from B to B dash, so that the current goes from B dash to B. That's going to change this to a south and that to a north. Yeah. And there's our slide with all the steps on it in one go. So there's our step 1, both ports in the normal direction. There's our router starting point there. Here is step 2. we've got A, we're on A dash and B, rotor's moved 90 degrees between there and there. Then we switch over B, so we've moved between there and there, and then we switch A back to where it was in the first place, so we turn on this port and we move between there and there, and then we move back to step 1 again. Okay, so it's a slightly different way of doing the full step for that motor, because we've always got 2 coils energized. Yep. And that answers the question you asked. Does that turn off briefly or does it stay on? There's the switching sequence, and as you can see from that, absolutely always got at least 1 coil energized. Can you think of implications of that? Good things about that? Yeah, so you always got some torque. Yeah? You're gonna change the amount of torque you've got, haven't you? Again though, it's effectively going to increase the amount of torque that you've got for that motor, because you've always got 2 coils energized, and even when one turns off, the other one's still energized. So overall, you're going to get more torque out of that motor by switching it in that way, because you've got 2 coils energized. Yep. The next bit, half stepping, combines 1 phase on and 2 phase on algorithms, and has the effect of improving the rotational resolution. It goes round half a step at a time. Yep. So how do we do that? Right. The sequence, instead of having 4 steps, has to have 8 steps to it. Okay? And what we do is, if we're starting from step 1 being ion only in the direction A to A dash current, as per the first slide, the rotor aligns with the north-south poles of coil A, and so we're starting from the position of the south pole being facing east in terms of my looking at this exercise. The next step will be to energize, leave A on and turn B on in the normal direction. So we're gonna energize this coil in that direction. What that's done is we've still got our north-south here for the A coil. We've now got a north-south for the B coil. The rotor has turned half a step from there to there. Yeah. The next step from here to here is to turn A off but leave B on as it is. So these 2 poles there and that one are going to stay, but these 2 are going to disappear. Rotor's gone from there to there. Another half step clockwise. And then to finish that off, we've got slide there. It's got 6 steps of the 8, although it's got the remaining steps on it. I think, yeah, this is where we just now finished off on step 3. Yeah, step 4 has us going a quarter step, where we've turned I on in the reverse direction, B on in its original direction, then we turn B off, but leave A dash on, then we put B dash on, turn A dash off, turn A and B on together, and then the next step is back to the first one we started with originally. Yep. So we've got an 8-step sequence. That means we've halved our step angle. Yep. So we can move in half the steps we did originally, just simply by doing the switching algorithm over. And that's the reason for having the double on coil in the first place, and then we can turn one off and turn it on in the opposite direction the next step and so on, and go round in an 8-step sequence instead of a 4-step sequence. Yeah? Bipolar half-step voltage sequence. Yeah? And if you look at them, they're turned on, each coil is turned on in a particular direction over 3 half steps. Yeah, once that comes on, stays on for 3 half steps and goes off, and they overlap each other. Yeah. But again, the speed would be controlled by the step frequency, or the frequency of each of these half step changes as it went through that sequence. And if we reverse the step order, the motor's going to go the other way. So it's very easy to reverse the direction. Half stepping considerations. So yeah, great, we can go in half step, but it requires double the clock pulses as you would need to use for full stepping. Alright, and there's implications with regard to the overall frequency that you switch at. Torque in half step mode is as in full step 2-phase on mode. Torque is half in half step mode as you would get in full step 2-phase. Alright, and then as your step frequency increases, you reach a point where you start to lose torque because of the speed you're switching it at as well. So like anything else, there's always limits to what you can do. Now I thought there was more to that than that. Let's just